This here you looked up for me online earlier.
Yes.
What is it?
It's citric acid.
So that is the molecular formula, or rather the chemical formula, I should say the chemical formula for citric acid. It tells us how many carbons we've got, which is 6, how many hydrogens we've got, which is 8, and how many oxygens we've got, which is 7. Now that's because it's an organic acid, that it's got such a big molecule, because organic acids tend to be big molecules, okay? Which means that it's heavy, which means that we need quite a lot of it. And if I just show you the packet, we got 50 grams of citric acid when I bought that packet many years ago. It's from a chemist. That's why it says Care Plus on it, with in that chemistry sort of that chemist sort of way. You can get it from baking shops because you use it for baking bread. So and you can buy that online. Okay, so that's actually quite easy to get hold of.
What do you use it for with baking bread?
I think it assists the raising agent and makes sure that your bubbles within your bread are more evenly distributed. I'm not entirely sure. It's just one of those things. It gets put into bread making at any rate, and you could look it up. It's one of those things. Have an investigate and see what you find out. Okay, so we were calculating the relative atomic mass of that. And basically we need to look up in the periodic table to see what they are. And here you can see, I have already done that for you.
Here's one we've done earlier.
Now, this is because I don't actually need to look these ones up in the periodic table.
Show off.
I know, that's showing off terribly, isn't it? Because carbon, hydrogen and oxygen, you're just using all the time when you're doing organic chemistry, which, of course, being a biologist, most of the chemistry that I do is organic chemistry. Okay. So, carbon has a relative atomic mass of 12, hydrogen has a relative atomic mass of 1, and oxygen is 16. So what we do to find the relative atomic mass of the entire molecule is that simple calculation. We go 12 times 6, because we've got 6 carbons in that molecule, plus 1 times 8, because we've got 8 hydrogens in that molecule, plus 7 times 16, because we have got 7 oxygens within that molecule, and obviously oxygen is 16. So I've done that there, and I've actually included my working for you, so you can see that I did it by hand. Okay, so you can see...
you could just add your working after doing it.
I could have added my working afterwards, but I did actually do it by hand. So there you go, those are the multiplications, and they add up to 192, which is the total relative molecular mass, because it's molecular mass because we're talking about a molecule instead of an atom.
So, and a molecule is loads of atoms bonded, stuck together.
Well, bonded together. We generally use the phrase bonded. But yeah, your stuck is glued, younger students. A molecule is lots of different types of atoms, not always different types of atoms, but lots of atoms stuck together, or effectively more than one atom at any rate. This one is a very big molecule, as you can see, because it's got lots and lots of atoms there. Right, so... Now, those of you who are studying Key Stage 3 and GCSE will be very interested in this, and this is a 1 molar solution would be 192 grams dissolved in 1 litre of water, as I've got written down there. So that's how I could make up a 1 molar solution. Now that would take 192 grams. Let's just take a look again. That's 50 grams.
We would need 4 of them.
Yes, we'd need 4 packets of that, and that's an awful lot, and we really are not going to get through that amount of it. Okay, we don't need very much of a solution at all. We could probably get away with about a 10 ml solution, but the problem is with a 10 ml solution, and I'll show you it now, is it goes like this. If I wanted a 10 ml solution, Okay, have a look at my 1 molar solution, which is 192 grams in 1 litre, which is also known as 1000 millilitres. To get a smaller volume of that, I could do 19.2 grams in 100 mils. Okay, yeah, so I divided it by 10 each, divided both sides by 10. So if I divide both sides by 100, then I get 1.92 grams dissolved in 10 millilitres. That was a bit spooky. So I get 192 grams dissolved in 10 millilitres if I do it like that. But
surely we want 100 millilitres then, because that's the most rounded number that's not...
Yeah, the problem comes is I've been using that citric acid for baking and for doing other practicals before.
So what, we might not have 19 grams of it?
Yeah, we have actually done a serial dilution of citric acid before, but you were very little when we did it, so you might not remember. No. And also we didn't video it to put onto YouTube. Right, so what I thought to myself was, how about we do half 100, which is 50 millilitres. Now, we know that we can measure 50 millilitres of water fairly easily because we've done that before. And I happen to know, because I've just weighed my citric acid, and there it is, that actually is 10 grams. So I'm safe in saying, if I take my 10 millilitre version, which 1.92 is actually a bit tight for measuring in grams on electronics kitchen scales, okay, because they only measure down to full 1 grams, okay, but we know from what you observed last time and what you've observed before is that if we can get the scales flashing from 10 to 9 to 10 to 9 to 10 to 9, we know that our mass on our scales is around about a half. It's around about halfway between 10 and 9.
Meaning we can get it.
We can get it pretty close to 9.6 grams in 50 millilitres. Okay. So that's what we're going to do, and we're going to demonstrate doing that